Hi there, folks. Today we're looking at adding and subtracting radical expressions. And so really we're going to look at when are we allowed to add and subtract radicals, and then two, once we figure out we are allowed, how do we add those things or subtract those things once we determine that we're allowed to do that. All right, so the first thing we're going to look at is when are we allowed to add or subtract radicals? And the answer is pretty simple. It's when we have what we call like radical terms. All right, like radical terms are simply same type of radical with the same radicand. All right, so same type of radical, meaning if one's a square root, the other one has to be a square root. If one is a cube root, the other one has to be a cube root. All right, and then the same radicand just means they literally have to have the same value underneath the root. All right, so if one of them is a 2 underneath, the other one better be a 2 underneath. All right, so something like radical terms, a square root of 3 and a square root of 3, a square root of 5 and a square root of 5, a cube root of 10 and a cube root of 10. Those would all be like radical terms. So basically the root portion, the radical portion, has to match exactly. All right, and if they match exactly, then we're allowed to add the radicals together. All right. Adding the radicals, kind of like adding like terms when we're talking about variables, really. We basically add or subtract the coefficients and the radical part stays the same, all right? Just like if I had a 5x plus a 2x, it would be a 7x. The variable part doesn't change, all right? So it's the same thing here, except the radical part doesn't change, all right? So they have to have the same exact radical, all right? And when we add them together, we add the numbers on the outside, the radical stuff stays the same. All right. For example, if I look at something like this guy, I've got a 3 square root of 3 plus a 7 square root of 3. And so the question is, am I allowed to add these together? Are the radical parts exactly the same? One of them is the square root of 3. The other one also has a square root of 3. Those pieces are identical, so I'm allowed to add these together. And again, I just ignore the radical part. I say, hey, look, let's look at the numbers out front, the 3 and the 7. I just add those together. That's a 10. And then the radical part, the square root of 3, just stays as the square root of 3. And that's it, okay? It's just like if I had a 3x plus a 7x, I would say it adds up to a 10x, all right? I add the numbers out front, I add the coefficients, the variable part stays the same. With radicals, I add the stuff out front, the radical part stays the same, okay? Same thing here, if I look at these guys, I've got 4 root 2 minus 9 root 2. So I have a square root of 2 in one, I have the square root of 2 in the other. Those are like radical terms because the radical part is identical. So now I subtract. 4 minus 9 is a negative 5. And the radical part stays the same, square root of 2. Okay? So the like radical terms tell me I can add them together or subtract them. I do the operation with the numbers out front. The radical part stays the same. That's it. All right? Now, it becomes a little bit more complicated when maybe I have a situation like this. And as I look at this thing, I've got the 2 root 24 plus 5 root 6 minus 4 root 75. Well, as I look at these, none of these are the same. The square root of 24, the square root of 6, the square root of 75, none of those are identical. So the way this is written, I cannot add these or subtract them in any way, shape, or form. However, these are not written in simplest terms. Okay, I cannot yet determine if these are like radical terms because I can simplify some of these. So I need to simplify these the way we've been simplifying these. So if I look at this first one, 24, any perfect squares divide evenly into 24. The answer is yes, there's a 4. It's 4 times 6. The next one, any perfect squares divide evenly into 6. No, that's only divisible by 2 and 3, and neither of those are perfect. So I'm just going to leave that as a 6. I can't simplify it. And then this one, any perfect squares that divide evenly into 75. The answer is 25. So 25 times 3. And now I start taking the square root. So if I look at this first one, the square root of 4 is a 2. So I already had a 2 on the outside. The square root of 4 is also a 2. The 6 is still trapped. This one I can't simplify at all, so I leave it the way it is. Over here, the square root of 25 is a 5. So minus, I had the 4 out here originally. Square root of 25 is a 5, so I add that guy out here, so I put that out too. The 3 is still trapped. And now I continue to simplify. On the outside, let's see, that's a 4 root 6 plus 5 root 6 minus 20 root 3. Now these are all written in simplest terms. As I look across, 2 of these have an identical radical. The first 2, the 4 root 6 and the 5 root 6. So I can add those together. 4 plus 5 is a 9, so it's 9 root 6. The radical part stays the same. minus 20 root 3. And there's nothing else I can do here. These are not like radical terms, so I cannot continue to simplify. That's it. I've simplified as far as I can. All right? So as you're approaching this, yes, we need like radical terms in order to add, but make sure you simplify the radicals first. It might reveal like radical terms to you. Okay? If I look at the next one, same kind of thing. I'm looking for perfect squares to divide into these guys. So the 50, that's 25 times 2. The 100 is a perfect square. I can leave it the way it is. I'll take the square root in the next step. And then the 5, there's nothing else I can do there. No perfect squares divide evenly into 5, so I'm going to leave it the way it is. And so now let's simplify. Here, the square root of 25 is a 5, so I had a 12 out here. I now also have a 5. The 2 stays underneath. The next one, the 100, the square root of 100. So I've been circling these things in red. The square root of 100 is a 10, so I had a 7 on the outside. Now I also have a 10. But there's nothing left on the inside because there's no other values there. I took the square root of 100, so nothing else left underneath there. And then this one kind of just stays the way it is. And now I simplify. That's a 60 root 2 plus 70 minus 8 root 5. And now I look for like radical terms, but I've got a root 2, I've got a root 5, and then one that doesn't have a radical at all. So none of these have identical radicals, so I can't do anything else here. I can only combine like radical terms, and I don't have any like radical terms here, so this is my answer. Okay? And the idea here is I still have to do what I did because that's part of simplifying. And a question like this wouldn't necessarily say add or subtract. It would say simplify. So I have to simplify by simplifying each square root. And then I continue to simplify by adding, subtracting if I can. Okay? If I look at this one, again, I've got a square root here. Now I have some variables thrown into the mix. And so as I look at this one, there aren't any perfect squares that divide evenly into 2. And the x to the 5th, I'm going to leave the way it is, and then I'm going to do my divide remainder type of thing. Over here, 8, I can break down into a 4 times 2. 4 is a perfect square that goes in there. X, I can't really do anything with. I'm going to leave it as x to the 1st. And now I start taking the square root. So this one, let me write the 5 down. The square root of x to the 5th. Remember, I'm dividing. There's a little 2 on the outside. I can't see it, but I know it's there. 5 divided by 2 is 2 with a remainder of 1. So it's an x to the 2nd. See, it went in there 2 times with a remainder of 1. So I'm going to put an x to the 1st left over on the inside. Okay. The 2 is also left on the inside. So I've got 5x squared on the outside. I've got 2x on the inside. The next one, once again, I simplified. The square root of 4 is a 2. So I already had one 2 out here. I put another 2 out here. The x squared was out here. And then I can't really do anything else under this radical, so I'm just left with the 2 and the x. Okay? I do a little bit more simplifying. And now I start combining. And there's a lot of layers of like terms happening here. First of all, like radical terms, I have a square root of 2x and I have a square root of 2x. So the radical part is identical, so they're like radical terms. But in order to add those coefficients, the 4x squared and the 5x squared, they have to be like terms also, which they are. Remember, a 5x squared and a 4x squared just adds to a 9x squared. The variable part stays the same. And likewise, the radical part stays the same. Okay? And so again, the thing I like about this example is showing that relationship between simplifying like terms with variables and simplifying like radical terms. It's the same thing. Add the numbers out front. The other stuff stays the same. Okay? If I look at this one, these are cube roots this time, so be careful. We're looking for perfect cubes this time. So 54, that's 27 times 2. Remember, 27 is on our list of perfect cubes. And if you need to go off to the side and make a list of perfect cubes, that's fine. All right, again, we're not as familiar with those, so that it takes a little bit more effort to do that. This one, the 16, don't be fooled here. 16 is a perfect square, but it is not a perfect cube. I need perfect cubes. 8 is a perfect cube. Okay? And so now, right here, the cube root of 27 is a 3. I already had a 6 out here. I put a 3 out here as well. and I'm left with the 2 underneath the cube root. Over here, the cube root of 8 is a 2. So I had a 4 out here. I get a 2 out here now as well. Under the cube root, I still have that other 2 that's left over. I continue to simplify. And now I ask myself, do I have identical radicals? I've got a cube root of 2 and a cube root of 2. They're identical, so they're like radical terms. So I subtract the numbers out front. That's a 10. The radical part stays the same, cube root of 2. Okay. So again, like radical terms, the radical part has to be identical. It has to be exactly the same. All right. If it is, I treat it the same way I do variables. I add or subtract the coefficients. The radical part stays the same. Okay.